Good morning, everybody. Please, I need your attention for a moment. We are going to start revising lesson number 20.3. And lesson number 20.3 is about force on electric current. What does it mean? It means that whenever current passes through a wire, okay, whenever current passes through a wire and wire is placed inside the magnetic field, it feels a force because of the magnetic field. That force is called force on a current carrying wire. If you say the amount of that force, how to calculate it, for that purpose, we will like to talk about first the magnitude of the force, and the magnitude of the force mathematically is equal to F is equal to I L V sine theta. What is what are the components here in F is equal to ILB sine theta? The first component is here. F is representing the force. What F is representing? The force. I is the current through the wire. L is the length of wire, Adil. L is the length of wire that is inside the magnetic field. So here B is the strength of magnetic field and sine theta is angle between magnetic field and length of the wire. That is it. If theta is 90 degree. Here you have to remember theta is 90 degree between, you can say magnetic field is perpendicular to the length of the wire. Then what will happen? We will say the force is maximum. Why the force is maximum? Because you know that when theta is 90 degree, sine 90 degree is how much? Sine 90 degree is 1. So sine 90 degree 1, when we substitute it, it will be equal to ILB only. So this is called the maximum force on the current carrying wire. But when you say that theta is 0 degree, what will happen? Theta is 0 degree between B and L. It means that there will be no force affecting on the wire. Why? Because sine 90 is 0. So you can say force will be 0 when this is it. So force is ranging from sine 0 to sine theta 0 to force ranges from minimum to maximum when theta is 0 till theta is 90 degree. Now come to the other point. If you are talking about the force, the direction of the force is very important. The direction of the force can be found by Fleming's right hand rule. What is Fleming's right hand rule? Fleming's right hand rule says that if you have three fingers of your right hand that are stretched perpendicular to each other, as you can see here, these three fingers are stretched perpendicular. So you have to follow the rule FBI. FBI. F is the force on the wire. B is the magnetic field. I is the current through the wire. I'm repeating my words. Yahya. F is the force, magnetic field, and current. So when you are talking about FBI, force, magnetic field, and current, so all of these should be perpendicular. So force is perpendicular to B and I, or you can say L as well. So as you can see in the diagram, FBI is the rule that will tell us the direction of the force. Now come to the figure. If you look at the first figure A in the bottom, the current is moving away from me and magnetic field is from north to south. So whenever current is this one and magnetic field is north to south, so what would be the force? Force will be, this is magnetic field, this is the current, this is magnetic field, force is downward. You can see the first figure A. So force is down. But when you have current toward me like this, and magnetic field is from north to south, so force is upward. So here in this figure, you can see force is in which direction? Force is downward, and this wire, this current carrying wire will feel a force downward, and this current carrying wire will feel a force upward. Now here is one more thing that you have to remember. The force, magnetic force that you call, is the direction is found by right hand rule, and it is always perpendicular to both magnetic field and current. So you have to remember that it is perpendicular to both magnetic field and the current. Now coming to the next point, if we are going to calculate it, so what we need to check? We need to check amount of force, we need to check amount of magnetic field, we need to check current carrying through it, we need to check angle between current and magnetic field. So to find the force, so here are the some options that you can see that if wire has current carrying through current I is perpendicular to the magnetic field. It means perpendicular to the magnetic field. What is the rule? The rule is F is equal to ILB. Hadi, when force is magnetic field is perpendicular to current, so you can say this is maximum force. So you have the maximum force here. I can just say Fm to show that this is maximum. Okay, this is maximum force. So when force is maximum, Hadi, force is maximum. Hadi, Yahya, please. When force is maximum, what do we have? We have ILB. No need for theta here. So they are saying when current I is perpendicular to B, length is the fixed. Which of the following changes the result in decreasing the force on the wire by a factor of 2? We need force to be half. We need the force to change to half. So if L is the same, if they are saying L is same, so what are the important points that will affect the force to change into half? Decrease in the angle from 90 to 30, decrease in angle from 90 to 45. So here, if you are saying angle, for example, angle is sine, you can say here I would write sine theta as well, because they are saying current is perpendicular but not the length. Length may have the angle here. So when sine 90, you know the answer is 1. Sine 45, what is the answer? 1 over radical 2. Sine 30, 1 over 2. So if you change the sine theta to 30, this is the first thing that change the force to half. Okay. So first thing, when you change it to 90 to half, not 45, 90 to 30, it will change it. Decrease the current I by 2. If you decrease the current, yes, it will also decrease the force, and decrease the magnetic field from B to B over 2, yes. So if you change the current to half, if you change the magnetic field to half, if you change the angle from 90 to 30, all of these changes will change the force to half, because it is half a factor of this. You got it? So now the next thing is, you have a straight power line carrying 30 ampere current, which is perpendicular to the earth magnetic field of this. This T is representing the Tesla. So you have to remember one thing that I didn't say. Magnetic field B is calculated in Teslas. What is Tesla? Tesla is also known as Weber per square. Okay. We were talking about that how much is the force on the current carrying coil. So here we have Tesla given the unit of the magnetic field. Now what they are saying what is the magnitude of the force? As it is clear that current is perpendicular to the magnetic field, so I will use the force. Can you please hold your calculator? I will use the equation F is equal to BIL. I don't need sine theta. Why I don't need sine theta? Because this is the maximum force. So force F is equal to B is 0.5 into 10 to the power minus 4 Tesla. We can also say 0.5 Gauss, because this is 10 to the power negative 4. B current is 30 ampere, and what they are saying perpendicular to this magnetic field of the straight power line. This is the current carrying conductor. And now magnitude of the force exerted on the 100 meter is the length. So can you please check the answer? This will be 0 0.5, 0 0.05, I think 0.15. Can you please check it out? 0 point? No, can you please check it out? This is 100. I think 0.15 Newton is the force. Okay. This is the force on the wire. Okay, next one, please. We have this situation in which we are going to find the magnetic force with the direction. But here we have been given by the angle. Adil, what do we have here? Adil, first of all, we are asked to find the force, and you know the rule, F is equal to IL V sine theta. So here is I equal to how much? The current is 30 ampere. Length of the wire inside the magnetic field is 12 centimeter. So I'm going to convert 12 into meter. From centimeter, I divide it by 100. And then magnetic field is 0.9 Tesla. I just substitute. And then the last thing is the angle, sine theta. If you look at the figure, it's given 60 degree. So sine 60 degree. Hadi, can you please help me out? What is force equal to? The amount of force. 2.8 or 2.6? Can you recheck one more time, please? 2.8 Newton. Farooq, can you please check it out? Okay, there is another thing, direction. Who will tell me the direction? Magnetic field is toward this direction, current is up. So for me, force is into the board. Into the board. Right? You are also showing me into the board. So force is into the paper if you will write on the paper, or you will just say into paper. Okay, here is very, very important thing, Hadi and Yahya, that we need to remember. There are two symbols that we use for the direction of the vectors. Direction of the force, direction of the magnetic field. Yahadi, there are two symbols that we use for the direction. One is named as dot and the other one is cross. What are these two used for? Dot is used for the vector is pointing toward you, like the arrow is coming toward you. So vector pointing toward you or out of the paper. We can say outward of the paper. And then cross is like arrow is going away from you. So you can say into the paper. So here, this magnetic field is to the left to right, current is in this direction. So if you want to show the direction of the direction of the force on this wire, you will show dot or cross. It is into the paper. Into the paper will be represented by cross. So you can put here cross also to show the direction of the magnetic field. So here we are almost done with the main idea. Let me do another example in which you can see there is a current carrying wire inside a magnetic field, and magnetic field is shown by the dots. What is the dot mean? Dot mean out of the board, out of this screen toward me. So this is dot. Now you have a force downward and current is passing from A to B part of the figure. Now what are the given things here? The length of the wire that is experienced in the magnetic field is 10 centimeter. And there is a large gap. The top portion of the wire is out, so we will not consider it. The loop hangs from the balance, which measures the downward force of 3.48 into 10 to the power negative 2 Newton. When wire carries a current of 0.245, what is the magnitude of the magnetic field? So you are asked to find B here. So if I change this one, the force is F is equal to ILB. Yeah, Adil, F is equal to ILB. Why I didn't put sine theta here? Because the force, magnetic field, and current, all of them are perpendicular. Magnetic field is out of the paper, force is down. So how can I show this one? I can show like this. Force is down, magnetic field is out of the board toward me. So current will be from A to B. So this one is it. Now you need to find B. So what I will do? I will say B is equal to F over I times L. F, the force here is 3.48. Can you please hold your calculator, Hadi? Into 10 to the power negative 2 over 0.245 times you have the length, that is 10 centimeter. 10 centimeter when we divide 10 centimeter when we divide by 100, it becomes 0.1 meter. Can you please give me the magnetic field's magnitude, please? 0.42. So magnetic field is 0.42 and unit is Tesla. 0.42 Tesla. Can you please confirm it? 0.42 Tesla. Okay. To have the complete understanding, I just pasted some questions from your 1.42. Okay, I will change it. So this is not 0.42, 1.42 Tesla. Okay, now this one 1.42 Tesla is the answer. Now I was saying I just have few questions for just a quick check. Did we understood or not? Adi, can you read the first one and give me the answer? The magnetic force on the straight wire carrying current in the magnetic field B is given by which equation? F is equal to BIL sine theta. So this is B. Farooq, can you answer the second one? In which situation does a current carrying wire experience zero force? When force will be zero? When force will be zero? Either when force will be zero, perpendicular is the maximum force. So zero will be when it is parallel. Rayan, what is SI unit of magnetic field? Tesla. And also Tesla is equal to Weber per square meter, or you also know that 10 to the power minus 4 Tesla is Gauss. So please keep it in your mind. Number 4, what happens to the force if current is reverse? If current was going to the right, suddenly, for example, current is going toward you, it is reverse. What happened to the force? Force is, for example, in this direction. So force will also be reverse. Is it increase or decrease? No change in the magnitude because we are not changing the values. So it will change the direction only. It will be reverse. Okay, Rayan, can you answer this one? Yes, please. When you reverse the force, automatically it will reverse the current, sorry, it will reverse the direction of the force. Okay, now this is, you have a wire, you are asked to find angle between wire and magnetic field. Theta is the answer. So how you will use the formula to find theta? You have F is equal to ILB sine theta. So if you need theta, you will say sine inverse F over ILB, if I am not wrong, F over ILB. So theta is equal to shift sine. F is 5 over. I is also 5. Length is 2 meter into B is magnetic field, which is 0.5. So how much is the theta? Theta is 90 degree. So this is maximum force that we can obtain from this equation. Okay, next one. In this one, you are going to find beta. So the question is to find beta because you can see answer is in Tesla. They are saying magnetic field strength. So B is equal to F over B is equal to F over what? It would be IL. So is it maximum force? They are saying maximum magnetic force. So it means no need sign for this one. So F is max. So when you are having max, you don't need it. Okay. Now magnetic field strength B is equal to you have F how much? 4.5 over 3 times 1.5. So 4.5 over 4.5. Which is 1.0 Tesla. So that is this one. Okay, two more questions quickly. The current is 2 ampere, 2 meter wire. Magnetic field is this. Angle theta is 30. Find the force. This is simple. F is equal to ILB 2 times 0.2 times sine 30 degree. So 30 degree sine is 1 over 2.1, I think 0.4. Can you please check it out? 0.4. So the force is 0.4. One last question. A wire in the length of 0.8 meter experiences the force of this, field of this. You have to find, you have the angle of 90, it means maximum. So current, same equation F is equal to ILB. So when you need current, that is force over length time magnetic field. So I is equal to force is 0.48 over 0.6 times 0.8. I think this is 1 again. This is 1 ampere. I just put the values which are simple to understand, and this is 1 ampere. So I am hopeful you guys got this one, and it is simple. You can say simple explanation. But what you need to remember one thing, that when